So welcome to lesson 2 for unit 4 quadratic equations. Today we're going to talk about how to solve quadratic equations by factoring. So we're going to start with the minds-on activity. Let's look at the difference between linear and quadratic functions. So pause the video, do the activity. So essentially you're going to take a look at these functions and tell me if it's linear, quadratic, or neither. Then unpause the video and check your work. Okay, so just a quick review. Here, the degree on the x and the y is 1, so we know that this is linear. Here, the degree on the y is 1. You have to be careful. Because it's in vertex form, you would have to multiply it out and then determine the equation in standard form to see that the x has a degree of 2. But because it's in vertex form, you know that it's quadratic. Here again, the degree on the x, the highest degree on the x is 2. The highest degree on the y is 1. So we know that this is quadratic. Here we have a square root, which is neither linear nor quadratic, so it's neither. Here, the degree on the x and y is 1, so we know this is linear. And here, the degree on the y is 1, and the degree on the x is 3, so we know it's neither. So just a summary of linear versus quadratic functions. If both the x and y variables have a degree of 1, the function is linear, and graphing this function will produce a line. On the other hand, if the x variable has a degree of 2 and the y variable has a degree of 1, the function is quadratic. Graphing this will produce a parabola. Now, last unit, and really up until this course, we've been talking about functions. So linear functions, quadratic functions, we've been graphing them. What we're going to transition now into is equations. So a review, solving linear equations. So what are some examples of linear equations? Something like this: 5 is equal to 7x minus 2, or 2 is equal to 3x, or x is equal to 5, or 2 is equal to 5x minus 3. So what you'll notice is that linear functions had both an x and a y, and they both had a degree of 1, whereas linear equations will only have one variable, at least for the ones we will be dealing with now. So we'll only have one variable, and whatever that variable is will have a degree of 1. I can also have something like 3m is equal to 9. That is still a linear equation because there's only one variable, and that variable has a degree of 1. So when solving linear equations, the goal is to find the value of x. I'm putting x and I'm putting it in quotations because you can really have any variable, so it can be m or z. So the value of the variable that makes the statement true. In other words, I want to find the particular x value I can substitute into this x to make the left side equal the right side, or the specific m value I can substitute into here so that the left side equals the right side. A reminder when solving linear equations is that when you move things across the equal sign, you do the opposite operation. So I'm going to write it as like this. When you have an add on one side of the equation, on the other side it becomes a subtract, and vice versa. So subtract becomes an add. So just a quick example of that, if I have something like x plus 3 is equal to 2, in order to isolate for the x, I need to move the plus 3 to the other side. When I move it to the other side, it becomes minus 3, and I know x is equal to negative 1. Okay, so that's what I mean. When there's a plus on one side, on the other side, it'll become a minus. Or if there's a minus on one side, on the other side, it will become a plus. The other opposites you need to remember is if there's a multiplication on one side, it'll become a division on the other, or a division will become a multiplication on the other side. And a quick example of that is if I had 3x is equal to 9. Here, the x is being multiplied by the 3, so to isolate for the x, I need to do the opposite. Divide both sides by 3, The 3's cancel out. I'm left with x is equal to 3. So these are the rules essentially you've been following all along to solve linear equations. So using those techniques, let's solve these linear equations. Again, this is completely review. So if you want to pause the video, try it on your own and then see if you're right, feel free to do so. So the one thing I do want to emphasize, whenever you're solving any sort of equation, we never like brackets. We want to multiply them out. So here we have 7 times x, 7x, plus 7 times 3, 21. And we did nothing with the 2 or the 16, so we write them as is. I can now simplify by collecting like terms on the left side. So that's 7x, 21 plus 2 will give me 23 is equal to 16. Again, the goal here is to isolate for the x. So I want to first get rid of this 23. If I bring it to the other side, it's going to become a minus 23. So on this side, I'm left with 7x. Here I have 16 minus 23. Then I keep simplifying. Here I have 7x is equal to, what's 16 minus 23? Well, negative 7. And to isolate for x, I divide both sides by 7. So I'm left with x is equal to negative 1. What does this value represent again? Well, if I take the negative 1 and substitute it into this x, and I work out the left side, it should equal 16. So it's telling me that value that makes this statement true. Similarly here, we see brackets. Let's get rid of them. So we'll multiply it out first. So negative 2 times x is negative 2x. Negative 2 times 3, negative 6. Here, 5 times x, 5x. And 5 times negative 4, negative 20 is equal to 1. You can simplify the left side, so collect like terms if it's possible. Here we have negative 2x plus 5x, which is just 3x, and negative 6, negative 20, which is negative 26, equals 1. Again, I want to isolate for the x, so bring the negative 26 to the other side, where it becomes positive 26. So 3x is equal to 1 plus 26, which is 3x is equal to 27. Now to isolate for the x, I divide both sides by 3, and I get x is equal to 9. Again, I'm going super quickly because this should all be review. So again, you take this x, and if you plug it into all of the x's in your original equation, the left side will equal the right side. So how do we know that the previous two questions are linear equations? Well, simply because the highest degree on the x variable is 1. Again, I wrote x variable because that's what we saw in these equations. If they used an m variable, again, the highest degree would be 1. So now let's use the techniques we've learned to try to solve a quadratic equation. So solve the following quadratic equation. How do we know that it's a quadratic equation? Well, same logic that we used to know that these were linear equations. The highest degree on the x variable is 2. Again, you can use any variable here, but regardless, its highest degree will be 2. So let's try solving this question. So we have x squared plus 3 is equal to negative 4x. Now, if we try to solve it like we did with linear equations, we would bring everything with an x to one side and bring all the numbers to the other side. So let's try that first. I have x squared. I'm going to bring this to the other side, so it'll be plus 4x. And I'm going to bring this to the other side, so negative 3. Why did we do this? Because that's what we tend to do here. Bring everything with the x to one side and the numbers to the other side. But this doesn't really help us because these are not like terms. We can't really add them. We're kind of stuck. We don't know how to proceed further. So in conclusion, we can't use the same techniques to solve quadratic equations as linear equations. So with linear equations, we had these techniques. We knew when to go to move things across the equal sign. We had to change their operations and eventually isolate for the x. But because this quadratic equations will have an x squared and possibly a number x, we need another way to be able to isolate for that x. And there are two techniques we'll talk about. The first one is solving quadratic equations by factoring, today's lesson. And the next lesson will be solving quadratic equations using the quadratic formula. So solving quadratic equations. What are some examples of quadratic equations? We have 7 is equal to 3x squared minus 5x. Another example would be 0 is equal to 2x squared plus x minus 3. Another example, 1 is equal to x squared. Again, how do we know that these are quadratic equations? Well, simply because it's a single variable equation, and also because the highest degree that we see on that variable is n2. So the highest degree here is 2, here is 2, and here it's 2 as well. So when solving for quadratic equations, or when solving quadratic equations, the goal is to solve for the value. And I'm going to put bracket s here. It's because sometimes we may have more than one answer as our x or as our variable. So to solve for the value or values of x that make the statement true. And just like before, it doesn't have to be an x. This is still a quadratic equation because the highest degree on the variable is a 2. So there are two methods, as I mentioned, to solve quadratic equations. In this lesson, we'll focus on the factoring method. So for the factoring method, you need to simplify both sides of the equation as much as possible, then bring all terms to one side of the equation, or one side of the equal sign. The other side must be 0. Factor the side with all of the terms, and set each factor with a variable to 0 and solve for the desired variable. So we'll go through these steps in a couple of examples. Examples: solve the following quadratic equations. Again, essentially what that means is solve for the x values that make this statement true. So following step 1, it says simplify both sides of the equation as much as possible. If I take a look at the left side, there's no like terms to collect. It's fully simplified. If I take a look at the right, again, fully simplified. There's nothing I need to do in terms of simplification. Number 2, bring all terms to one side of the equal sign. The other side must be 0. If I take a look here, this side has 2 terms, this side has 1 term. The easiest thing for me to do is bring this term over. Okay, and when I bring this term over, again, because I have a negative 4x here, when I bring it across the equal sign, it's going to become a positive 4x. So I have x squared plus 4x plus 3 is equal to 0. Notice that I specifically put the negative 4x, which became a positive 4x, in the middle because this form is more familiar to us when we are trying to factor with the x squared, ax squared first, then the bx, then the c. Once I've done that, it says factor the side with all of the terms. So I'm going to factor this side. So I see a trinomial, but before you see that, you should see if there's a greatest common factor. 1, 4, and 3 doesn't have a greatest common factor, so you can move on to trinomial factoring. So I know this trinomial will be broken down into 2 brackets. Again, the first terms in the brackets will multiply to give me x squared, which is just x and x. And the next 2 terms multiply to give me 3, which is 1 and 3. Then I do the double smiley. So 1 times x is x. 3 times x is 3x. Again, I need to put in signs here so that these two terms add up to the middle term. I have x and 3x, so if I add both, I will end up with 4x. So I can put a plus here and a plus here. So now I'm done step 3. Step 4, set each factor with a variable to 0 and solve for the desired variable. So we kind of saw this previously when we were looking at quadratic functions and we were trying to determine their x-intercepts. It's a very similar process. However, we didn't start with a function in this case. We started with an equation. So we have two factors equal to 0. So we're going to set each factor to 0. So we have x plus 1 is equal to 0. So x is equal to -1. And we have x plus 3 is equal to 0. And x is equal to -3. So at the end, your final answers are -1 and 3. Sorry, -3. So something to be careful here. Can I convert this to x-intercepts? The answer is no, because x-intercepts are a property of functions. We didn't start with a function here. We started with an equation. There was no y variable we had to set as 0 to find the x-intercepts. Here, we're simply solving for the x, so you just write your answer as x is equal to -1, comma, -3. Let's try another example. So we have x squared is equal to 4x. Again, following the steps at the top. So the first step is to simplify both sides of the equation as much as possible. If I take a look here, again, both sides are simplified. There's nothing I can collect. Next, it says bring all the terms to one side of the equal sign. The other side must be 0. I have one term on either side, so I can bring the 4x over here or the x squared over here. General piece of advice is if the value attached to the x squared is positive, keep it that way. It's just so much easier to factor at the end. So we'll keep x squared on this side because it's a positive x squared, and let's bring the 4x over. When I bring the 4x over, it's obviously a positive 4x on this side, so it becomes a -4x on the other side. I'm left with nothing on this side, so it becomes a 0. Factor the side with all the terms. So I take a look at this, and the first thing I should think about when I am factoring is factoring out a greatest common factor. So does x squared and -4x share a greatest common factor? Well, of course, it's the x. So I can pull out an x from both of these terms. So x times what is going to give me x squared? Well, x. And x times what is going to give me -4x? That's just -4, which is equal to 0. So now I've successfully factored my quadratic equation. And now I set each factor to 0. So keep in mind, there are still two factors here. There's this one and this one, even though this is not in a bracket. So the first factor we set to 0, and there's really nothing else to do there. X is equal to 0. That's a solution. Then we have x minus 4 is equal to 0. Again, to isolate for that x, I bring the -4 over to give me x equals 4. So my two zeros, you can write your final solution as x is equal to 0, comma 4. Again, I want to emphasize that point that we are not finding the x-intercepts here, so we don't convert these to coordinates. Here, we're only finding the specific x values that make this true. Let's move on to example C. So again, it says simplify both sides of the equation as much as possible. So this side, there's no like terms to collect, and the 0, there's nothing we can do there. Bring all the terms to one side of the equal sign. The other side must be 0. Well, all of the terms are already on one side, and the other side is 0. So that's been done for us. Factor the side with all the terms. So let's start with that. Here, again, you start with a greatest common factor. Is there a greatest common factor between 6x squared minus x and minus 2? Well, the answer is no. So we know we can either do difference of squares or trinomial factoring. This is clearly a trinomial. So let's open up our two brackets. And again, we're going to make that equal to 0 because we're not touching the 0 on the other side. The first term is 6x squared. So the first terms in each bracket should multiply to give us 6x squared. I know I'm going to have an x and an x. That gives me the x squared. To get me the 6, so I have two options here, 1 times 6 or 2 times 3. Again, go with the closest ones first. So we'll start with 2x as well as 3x. The next two terms have to multiply to give us 2, which is only 1 times 2. You have two options, putting the 1 here and the 2 here, or the 2 here and the 1 here. But keep in mind that within the same bracket, we can't have two numbers that have a greatest common factor. So we can't put the 2 here because the 2 and the 2 can then be pulled out. They share a greatest common factor. So the 2 must go here and the 1 must go here. So in the middle, we have 1 times 3x, which is 3x. And the outer smiley, we have 2x times 2, which is 4x. And I put my little circles because I know I need to put signs in there so that it adds to give me this middle term, which is negative x. So to get to negative x, I need a positive 3x and a negative 4x. So because the positive is attached to this smiley, the positive will go here. And because the negative is attached to this smiley, the negative will go here. So once again, we've successfully factored out our equation. Now what we do is set each factor to 0. So again, there are two factors here. So 2x plus 1 is equal to 0. To isolate for x here, I'm going to bring the negative 1 over first. The positive 1 over to make it a negative 1 on the other side first. So negative 1 is equal to 2x. And to isolate for this x, I'm going to divide both sides by 2. And I'm left with x is equal to negative 1 over 2. That's one of the solutions. The other factor I have is 3x minus 2 is equal to 0. I'm going to bring the negative 2 over to the other side. So it's going to be 3x is equal to 2. And to isolate for the x, I'm going to divide both sides by 3, leaving me with x is equal to 2 over 3. So your final answers are x is equal to negative half and 2 over 3. I want you to pause the video now. I want you to try the other two questions yourself. And then when you turn on the video, I'll have the right answer for you so that you can check your work. I know this looks daunting, but remember the first step always is to simplify both sides of the equation. So simplify all of this first, and then you'll see that it's exactly like every other question. So pause the video now, try it, and then come check your answers. So here are the answers. I just want to emphasize a few things here. So we brought everything to one side. Remember, you always start with greatest common factoring first. There was no greatest common factor here. We did have a difference of squares. So just a reminder of what that is if you can rewrite both terms as something squared, so 25x squared is 5x squared, and 1 is 1 squared, and it's a subtraction, so a difference, then you can copy the 5x and the 1 twice. One factor will get a positive, one will get a negative. Everything else works the same. Set each factor to 0 and solve. Something I do want to show you is this is another way of writing the final answer. So instead of writing x is equal to 1 over 5th and negative 1 over 5th, you can also write it like this, which just means x is equal to both the positive and negative versions of 1/5. Here, again, all you had to do was simplify. So do FOIL, multiply out the brackets, collect like terms. Then when you bring everything to one side, it's exactly like every other question. Look for a greatest common factor. There were none. Then do trinomial factoring. Set it to 0. Or it's equal to 0. Set each bracket to 0 and then solve. So m is equal to 1 and negative 12. So the homework is handout A, 2 to 4. Make sure you submit these on the Google Classroom. Thank you.